Hello everyone, welcome. I'm hoping I'll be back to be able to answer and participate, but I'll set this up as a premiere, so a little different format today. I have to make sure that that certain events take place today, given what day it is. I'll let you guys do the math on what that means. But in the meantime, there were a couple weaknesses that we saw in the exam results. So there's a couple things that we're going to do in order to make things function. There's a couple pins, there's a couple pieces, so we're going to take a look at this kind of assembly and how to get this correctly defined for the example that they've given us here. So they can give us the origin, they give us the center lines for things, they give us the overall dimensions, so we're going to refer back and forth to this, but there's at least a consistent type of part, so we'll be able to fairly quickly put this all together, but we want to make sure that we're careful in how we're setting this up. So here's the way that I would approach this, where a lot of you start thinking, oh look, a rectangle, and then I'll make another rectangle, and then I'll make another. Nope, wrong kind of thinking on this. So instead, you want to do it this way. You want to think, oh, I actually have an L shape on the edge. I have an L shape, and then I have a 30 millimeter length on the one side, and 20 millimeter length up to this height, another 5 millimeter. So this is going to be another 30 millimeter by 30 millimeter bracket, because this is going to be about a 5 millimeter height. I'll explain why I know that here in a second. It has something to do with this radius. So we're going to quickly create this part as an example. So we're going to start our sketch. We'll start on right plane. We're going to have, nope, I don't want a center point rectangle. I want a corner rectangle, because I want this, and then I want this, because this is the shape that I want to use. This gives me the most features in this case, with the least amount of work. It's a little hard when it's an L bracket, because you're split between one and another, but in this case we want to just make sure that we have the detail that we need. So this also needs to be 30 millimeters, so make sure again your unit scale is all correct. This thickness needs to be 2 millimeters. Same thing with this. Now I can come in, do my trimming. Then on this side I can do a radius here and here. I'm going to do them one at a time, however. See if I can get them to cooperate. It may not. And that inner radius I think is in fact different. So let's take a look. That inner radius, yeah, that's a lot smaller. So that inner radius is going to be a radius of 1. That outer radius is going to be the radius of 3. Even though they don't specify it, they're using the 1 millimeter radius a lot of other places around the corners. So that one's going to be a 1 millimeter radius. That's how we know. So that inner one is 1 millimeter. This one is going to be a 3 millimeter. That might be a 2 millimeter. We'll see. Let's take a look. Yeah. This one. Two millimeter. Let's see. 3. It's too large. Interesting. Very, very interesting. So this is the dimensions that you play around with internally. It can sometimes be a little bit of work. 2 won't display, 3 won't display. Okay, so it might have to be a manual radius curve based on this. So let's take a look at how this was done. Yeah, they have a 3 millimeter radius arc. So what we might have to do is we might have to change this to have a 3-point arc. It'd be somewhere like this. Not actually making contact there. Then use our smart dimensions to make this have contact. Let's see if I can get rid of it, which is often very tricky to do. There we go. So this radius needs to be 3 millimeters. Then you come back in with the smart dimensions and you move it. Because if you had done a bunch of rectangles, what you'll end up with is you'll end up with a bunch of constraints that won't work very well. So that length can be 3, and then I need to specify this length to be 3. This is going to be as good as we can get to get the part behaving the way that we want. So this is correct, but in this case we couldn't use that fancy feature. We had to use some of our ingenuity here. So we're going to delete that other dimension. There we go. So we have our 2 radii. Now we're going to have to check our overall dimensions because we've lost some of our detail here. So that needs to be 30. That's already 30. Great. Okay. And the radii, at 3 and 3 gives us some of our dimension, and then this guy, this inner curve, has a second point for the radius. We've already defined the radius. We've already got the distance in X and Y defined. The only thing maybe that it needs additionally is something like this diagonal difference. Yeah, it's missing some important detail about the starting and ending point of these. So for this, it's not super important to have this part of it fully defined, since we're not changing the part itself. It has to do with the point of the radius, but as I've already defined the radius for this, I don't know that it's going to help any to try and get more detail, because it's going to try and pull the radius of the other origin. So we've already established the point of the origin. We've already established the radius, so there's not a lot else we can do there without breaking some of the other associations. So it's not worth the time to chase something like that. So instead of spending another 15-20 minutes trying to redefine that, we're going to go ahead and extrude as soon as we know extrude to what, 20 millimeters. So we jump over to our features, we extrude 20 millimeters, doesn't really matter which direction. Now we can add, so we've got 3/4 of our features there. We have some options on how to approach the rest of it. There's going to be these cuts in both, and there's a notch on one side, so it's going to be easiest to take a look at this. We can now do our fillets at all 4 corners, because that's a feature that we can't do easily otherwise. So it helps to be able to zoom in. So we get our fillets in. Now we're going to do the circles and then the cutout here. So if you're doing one operation like that, it's reasonable to do just a sketch on a surface. But now we want to change our view so that we don't waste any time trying to judge, oh, is that the right way to do it? Is that not? And you use center lines on these sketches to make your life easy. We're going to do another center line. We're just going to make this one horizontal, because we know that these dimensions are about 10 millimeters, and that's the center of our circle. So we've already got our circle. You want to zoom in a little bit. There we go. The radius of these is about 5, so we have a 10 millimeter diameter. Diameter. You're going to have another rectangle down here. So this height is going to be 10. That height is going to be 5. And we know that this is not 5, it's a depth of 4 millimeters based on the drawing. So we have our cutouts for the first one. So we're going to go ahead and do our extrude cut. We're going to go through all. Done. Okay, same deal. We're going to do the other sketch on this surface, reorient the view so we don't waste time with references. Center line. Another center line. Make sure it's horizontal. Set the distance. $10 millimeters. That's the center line. So we set our radius to be 5, our diameter to be 10. Let's see. Now we do diameter of 10. Yeah, that's the only other feature that we have here. Through all. And we're done, aside from specifying whatever material they tell us, which in this case, 6061 alloy. So we go ahead and set that. So 6061 is going to be this one. We want to make sure usually that when they specify it, it has the correct mass density. Sometimes they're going to specify that on the sheet. So 27 grams per cubic millimeter. When you do some unit conversions, that'll be the same thing as 2700 kilograms per cubic meter. So 0.27 grams per cubic millimeter. When you do the conversions, it's going to be the same thing. So that one's correct. So make sure that's applied. And now we have our part done. So we save that. So we're going to do now we need our pin. That needs to be a separate part. So we're going to create a new sketch. And what is that going to be? That's going to be a pin with a depth of the thickness of 2 of these plus 1 millimeter. So that's going to give us a thickness total of 5 millimeters with a 10 millimeter diameter. So this one's really simple. I already told it top plane, but whatever. Millimeter diameter, 5 millimeter depth, because 2 millimeters of thickness plus 1 millimeter space plus 2 millimeters of thickness is 5, unless this year is much worse off than what I think. This material presumably is going to be different, so they're saying titanium. This is why we got to pay attention. So edit the material. Titanium. All right, save this. And this process obviously takes a lot longer, trying to explain details, features, etc. Adds, in my experience, about 25 to 50% time. So now we're going to put together the assembly. So this is where we want to pay really careful attention. We need some more parts, because we need 3 of these. And 1 more of these. All right, so simple and quick enough. You guys should know by now, instinctively, one of the things that we're going to do. We're going to add some concentric. Let's start with this one, since this one is floated, or since this one is fixed. We're going to do another one. So we want to pay attention to the orientation here. So this is the one that I started with. It's the reason I drew it in this orientation, didn't do something else wacky. I wanted to start here. Next, I'm going to bring this one into place. So I do that with this single concentric mate. Now I'm going to flip and do an anti-alignment, because it's going to save me a little time. Now notice that we're putting that notch up to this side, so this is going to be up relative to our coordinate system. Now we're going to set up a distance mate, because that's what it calls for, a distance mate between this face and this face of 1 millimeter. But we need to not flip the alignment, but we need to flip the direction so that that is now 1 millimeter separated. And what we need is to bring another, either a coincident mate or a distance mate. Either will accomplish the same thing between that face and this circle. So now our pin is set, and we can set the angle while we're here. So we can select an angle, but we need to know between what and what. So the angle between this edge and this edge is going to be 45 degrees. So angle mate between this face and this face is going to be 45 degrees. If it was doing something wacky, we might have to change the alignment versus anti-alignment. We might have to flip the direction, check alignment versus anti-alignment, etc. In this case, it's actually doing what we want for once, which is a surprise. So then we accept that. So then we've now got 2 of our features up. So now we're going to set the third. So we're going to start with the pin. We're going to do a concentric between that cylinder and this one. Don't worry too much about alignment yet. We can go ahead and set a coincident between this face and this face to get us into the ballpark. Then we've got 1 more, so we need to pay attention to where that notch goes. So it's actually this leg. We're going to do 1 more coincident between these 2. And we're going to keep that same orientation, but what we're going to do is then set a coincident between this face and this face. So you can likewise set a distance between those 2, but it's going to give you the same net effect. All right, now we're getting the last relation between this one and this one of 45 degrees. So the last angle set between this face and this face. So here's where we'll see we have to play around a little bit again with the 45 degrees, but we need to play around with the angle. Sometimes we have to do the flip dimensions. Now we've got what we need. So this is what we're supposed to see based on what we've got here. Okay, so we've got all of our gaps, all of our details, all of our radii. Now what we need to do is set up this corner. Now, the reason this one is tricky is they're setting up a corner with a reference at this point. So as best we can tell, it's where the corner sort of would have been. So they're probably using roughly here as a reference point. You could use it here at the midpoint, and that should be okay. And that's what we're going to do in this case. So we're going to stop with the mates. We're going to add a reference coordinate system. And we're going to use this direction. Now, they give us specific details about negative z, negative x. So it should be x, y, z. Let's check where we have the orientation right now. We have x going this way, y going up, and z going out. So we need to rotate this basically around the y axis. So if we look, we can get it to about 90 degrees here. Now we have y going up. We have x going into the plane. And we have z, positive z, coming out into the part. So this is what we're looking for. There we go. So this is what we're looking for in terms of orientation. Positive y, positive z, positive x. So it's very important to pay attention to those directions. Now, based on this, what we should see is we should see center of mass being one of these options. So we go to evaluate center of mass. And we need to change our coordinate system. So this is what we see here. That's not changing. Interesting. Not enough. So we have, okay, maybe that is. So 39.94, 24.33, 20.46. 20.46, 24.33. So we are very much within a few percent of this range. So the answer clearly here would be C. So we want to pay attention to all those little tiny details here. We can see that this is fairly quick to do this individual assembly without any of the additional delays and explanations. It obviously goes much faster, but you should get down to the point where you can do an assembly like this from scratch, creating the part in about 20 minutes is kind of ideal. So the best way to do that is do it again and again and again and again. So go back, rewatch it, start from scratch with new parts, do it again, see if you can find ways to do it faster and more efficiently. You can try doing it with the rectangles and see if in this case that might be faster. Maybe it is, maybe it's not. You're still going to have to play around with the way that these fillets work and create some headache there. That creates some additional work that has to be done. So then there's a couple more things that we'll have to do. I'll switch over and we'll create a part here and from this same exam. So we'll do another example because we don't have any more assemblies. We already have a video on creating this as an assembly. So go back, watch it, redo it. We'll create this part. So we will think about, so I'll do this part and show what I would suggest is the best opportunity. Starting with a single block and a rectangular extrusion is the longest, most excruciating possible way to do it. So don't do that. There are a lot of features here that you can capture for a single sketch. So we'll show what that looks like and some ways to go about this instead. That'll be a little bit easier to manage, because there's easy ways to do this and then there's hard ways to do this. So we want to make sure that we're making as much sense as we reasonably can. So that'll be part 2 of this. Okay, let's look at the second part here. So there's a couple ways that you might think of to create a part like this. This is the kinds of things like you might see on an exam. There's other examples. We've done this part. We haven't done this one yet. We'll do that one in another class probably. But we're going to have to start the 4-wheel drive car project soon. So what do you do about a part like this? The best way to approach it is to think about how do you get the most features possible for the least work and effort. Now, this is going to require kind of a new and different technique. So we'll talk about what that looks like. There's going to be a couple features that this requires. So the best way to think about it is on this side. Instead of trying to create all of this other detail and trying to create part of this extrusion and things, which can be done. It can be done. The problem comes when you try to create some of this surface detail and do the arch cut and things. It's very doable, but there's a slightly easier way to capture basically all of this detail and then create that onto the part. So we're going to show you what that looks like. So first things first, we draw the features along this side. So it's 200 long, 40 high, and A is 100 deep. Okay. So we're going to do a right plane. We're going to create our 200 long. We're going to create our 40 high. And then we're going to create some of the features on this surface. So we've got a couple rectangular blocks on the bottom side. Let's switch back to this. A couple rectangular blocks on the bottom side. So we can either cut away some of it, but most of this, the way I've set it up, it's down below. So we're going to do that. We're going to maintain this center line, and then down below at the center, they give you this nice little center line that happens to be centered right along those dimensions. That's how you know. Happens to be centered. So we're going to make a reference center line, and that's also where our radius is going to come. Very important. We're going to make a reference center line at the midpoint. Okay, reference center line. We're going to make a couple of our blocks here. So they're about 10 thick, 10 millimeters thick, and we'll work on getting the spacing just so. These are, let's see, 37.5 wide. That first one is. So 37.5 wide. So that, yeah, the second one is going to be close to that same size, but not quite, and you'll see why. So 37.5 wide. So 37.5 wide. This edge is 50 millimeters from that edge. So here to here should be 50. So we're close, but not quite. This separation needs to be 25. So again, we're close. And this edge to this edge needs to be 100. So again, we're close. All right. So those two do appear to be the same size, and they should be based on 75 divided by 2, but you want to double check based on other references because they won't always give you nice symmetry in that way. So that's an important aspect, and these are 10 millimeters thick. So then we want to capture a few other things, one of which is we have a line at 60 that corresponds with the start of this radius, and this dips down below. So we have a height of 25 here, and that 25 extends all the way back except for right here. So what we'll do is we'll extend it out to this edge where 60 is. So this becomes 140 total length. So 140 millimeter. We're going to do a rectangular cut out of the top. Nope, got to start at the top. I have a really bad screen glare at the moment, which thankfully you won't see on there, but makes it very difficult from my end. 140. And this thickness here needs to be 25. So that thickness needs to be 25. Now, this range is where we see 60. We're going to have to mark using our center arc here a radius. This doesn't go to the midpoint, which is what we were trying to avoid, so we do make contact, but we can now make some set points. Like we can say, hey, this has a radius of 50. We know it has a fixed endpoint there, and we know it has a length. So we're going to fix a length of the arc. So 15. Let's see, do they give us a reasonable ending point? It looks like not. So it looks like we have to make kind of an arbitrary decision. Except they do mark this point here, the depth of 5 millimeters. So this is a very, very important detail we have to pay attention to. So this point here, the distance between this point and this point in the arc has to be 5 millimeters. So how do we do that? We do a center line. We create a point using a reference center line here. And that point now, we set the smart dimension so this is close but not quite 5 millimeters. There we go. So now we've artificially set our distance. This center line is still anchored to the center line here. So we have the reference points that we need. I'm going to double check that we don't have anything unusual with our dimensions, that nothing changed. Yeah, Looks like there's no horizontal separation. I was just confirming that. Good. So we have our radius of 50, and we can do our extrusion in 2 parts. We want to make sure that all of the features, there's no other designs or anything else on the side, so we're going to ignore the 2 top parts for the moment, because you can get lost in a ton of issues with regard to that. So what we're going to do is, now that we've got our sketch defined, we're going to extrude, but we have to pick which contours. So this contour, this part, goes the entire length up to this point here. So that contour goes all the way up unto, this is a depth of 30, A is 100, so for 70 millimeters, this is the uniform extrusion. So we're going to do the 70 millimeter first. And there's a reasoning for the madness here, so hang in there. We're going to do one more extrusion from this same sketch. So again, you can reuse the same sketch by selecting it from the part tree here. It really can save you a ton of time. So then what we need is, we need to think about, okay, I need this region, I need this region now, but I need this to extend from the surface here. We also need this region and this region, because those go all the way, right? And that distance is the rest of the 100, the 30. So this is 30 millimeters. So in doing this, we've created about 60% of our geometry with one simple sketch, and done without pausing, explanations, etc. This can take only a few minutes to set up if you're paying attention and using the strategies that I'm showing you here. So it's very important to pay attention to the details. Now, what this is going to do is allow us now to start focusing on adding in these features, because this is the full width and thickness, but it's on this inclined plane, and this one is also on this inclined plane. So there's some easy ways to do this, and then there's some hard ways. We're going to try and do it the easier way here. And what we're going to do is, we're going to set a distance A of 100. We're going to set a reference plane here. So we're going to need our reference geometry. And we need a separation from this edge, offset of 100. We need one of those planes. So this plane is going to be a reference point for us in terms of creating the plane that we need. We're going to need another reference plane, and we're going to need to reference this one, but we're going to be at an angle of, based on our data here, we're going to need an angle of 30 degrees. So these are a little bit more tricky as far as references. 30 degrees from, and even instead of this plane, we really need to use probably this surface and have it be at 30 degrees. But we also need a reference. It needs to go through this plane. And we need this reference at 30 degrees. So we should be able to see a reference. We might even be able to change our reference to be top plane at a 30 degree angle. And then we need to make sure that it touches this edge and this edge. So let me see it doesn't want to use, let me delete this edge and switch it. We can create a model intersection here artificially, but I'm trying to not add extra confusion to you guys. So this offset, this gets us the correct plane orientation. And what we can do is then create another parallel plane. Sometimes you can include a reference here and have it coincident. It's difficult to do that. It's difficult to set kind of a reference of an angled plane. So sometimes what's going to be easiest and fastest for you is to get a reference plane like this, hit OK. So you have a reference plane. What you're going to do is you're going to make this a little bit bigger so that you can visualize it. And what we need now is just an offset from this to actually make contact with that surface. So what we're going to do is we're going to reference that plane. So we're going to do another reference plane, and we're going to separate that with a distance offset, but we're going to dial this back and start with about 10 millimeters. And we're going to bring this down, because you can increase this in steps. And right here, we can sometimes, for instance, make a coincident, but sometimes doing a manual set is going to be as close as you can get. So we're going to say OK. And now we have our reference plane that we need, plane 3, to do this feature sketch on. We can take plane 2 and we can hide this one without creating other issues. Now, similarly, we're going to need a reference plane for this one that's going to be at 20 degrees. So we're going to do the same kind of thing. We're going to say a reference plane, and we're going to say this edge, and we're going to collect this face 30 degrees with a flipped offset. There we go. So we've got what we need here. We maybe could have put some reference points on that plane that intersect with this model, but it would have added some additional steps. So there's a few different ways, as long as you understand there's a few different ways to go about this, you're going to be okay. So we've got our 20 degrees. Okay. So let's start with this one because it'll be fairly quick. So now you're going to create this part. You're going to do a rectangle from that edge, 40 by 50. And then you're going to create an arc at the top. So you're going to sketch on this plane specifically. So it helps to click the specific plane of interest, or right click, add a new sketch, so that you know exactly what plane you're sketching on. So we need that 40 by 50 rectangle. We can use this reference edge. We set our smart dimensions, 40 by 50. We're going to cut that part away, so we're going to leave this alone by 50. Okay, 50 wide, 40 tall. Now we have the arch, and then we have the circles. So don't worry about some of the other detail for now, because all of this will make sense in just a second. Oh, interesting. That was not quite the center line of this line. There we go. You have to highlight it orange because reasons. Yes, yes. And then we have our two circles. So we have an inner circle and we have an outer circle. All right, those dimensions are radius 25. Yep. Separation distance from this edge is 15 millimeters. Pretty close. Good. So the separation for these guys is also the center lines for all of our axes for our circles. Same deal. So radius of 12, and then so diameter of 12 here, and then diameter of 25. Diameter of 12, diameter 25. Yeah, the second one should be close, and it is. All right, so there we go. We have our feature already sketched. We're just going to do a couple different types of extrusion. And what we're going to do is leverage the power of this extrusion by saying, I need this one and this region and this region all to go into the surface, but instead of blind, we're going to do up to next. And that's going to take care of meeting the geometry where it needs to be here. But we're going to make sure that that region, that interior region, is selected. So we've created this part. We now need to do the one more extrusion here. So we're going to extrude from this sketch. All right, I'm going to step out of that sketch because it added another feature sketch there instead of the boss extrude. Occasionally that happens. You got to pay attention to what your tools are doing. From sketch 2, this region becomes, this region goes up 15 millimeters. This is probably a through-all hole. Looks like. Yeah, so I'm going to make that as a through-all hole. So I'll do one last step there, but this is 15 millimeters. Okay, 15 millimeters. This needs to be a through-all hole. So I'll do a quick extrude cut. Again, referencing that same sketch. It'll be this. Through-all. All right, so now we have that feature created. Same thing, what we're going to do is we're now going to take that plane 4, kind of get it out of our way. We're going to hide it so that we aren't watching it. We're going to use this plane as this kind of point of intersection for this bottom one. That's going to help make life just a little bit easier when we go to create this sketch on this specific plane. So we're going to do the same thing. We're going to create a rectangle, and we need to create it in such a way that it crosses or intersects that surface. So we're right there on the surface. It needs to go the full width. So we'll set our smart dimensions, 70 wide, and then height is going to be 50. So note that it is using kind of this surface as a reference, and so we are extending up above this surface, which is what we wanted. So we're going to change our orientation so that we're kind of looking dead on to the sketch, more or less. That'll help kind of keep our our reference points here specifically, like trying to get that orange reference for a center line becomes very important. So now we're going to trim this guy out because there's a couple things that we need to do. So there is still going to be the two circles. We have to get off the trim entities. So there is going to be the small inner circle. There's going to be the large outer circle. And we're creating this geometry. So we're going to have, based on this, we're going to create just these two rectangles. Center points won't really help here. You really have to have left or corner rectangles for this. So we'll set some of the key parameters here. I'm just trying to go for a couple key associations, like connecting at the bottom, extending at the top, because I'm going to end up cutting away some of the rectangle anyway. So we set the heights to be 10. We set the distance here to be 5, so that these are on center lines. Same thing. Set this to be 10. Set this distance to be 5. So instead of trying to create all of this geometry from the side, which you kind of can do, and then you're still going to have to come back and make a face and a sketch. So you can try some practice methods where you try and do an extrude of this profile from the side, but it's only going to help you so much because you're trying to create a very intricate geometry here. So I then cut out the parts I don't need. So we leave those parts off. We then check what pieces we need. So we have an outer circle. This one has a depth measurement. So this is a diameter, and this has a couple different depths as a measurement. So this has a depth of 5, and that's what this depth 5 is saying for this one. So we have a pair of radii. So there's a 25 and a 15 is what this is trying to tell you. So you have a diameter of 15 down below the 25 here at a 5mm depth. So we'll talk about how to recreate that, but we don't need some of this other detail. So we're going to do a 5mm cut of most of this geometry, and then we're going to do a through-all cut for this inner hole. So these pieces go away inside the circles. So all of these go away, and you're left with the geometry of interest on that surface. So now we can do our extrude, and then we'll come back and do the extrude cut. That'll be the easiest. So we need to extrude. We need all the regions. And I'm going to go ahead and include this, even though it's going to be a through-all cut. We're going to switch directions. We're going to go up to next. On the sketch plane, we can do up to body. In the direction of in the direction of this side. We need to go for this one. There we go. We need all of those regions up to next from the sketch plane. Okay. So it's not... Alright, so the extrusion there, we should be able to do an up to next most of the time. You can usually do up to body. You can do up to surface, typically. But it looks like it's going to be easiest to tell this just to do a blind extrusion. Sometimes you can fool it by selecting something. We're going to switch it to be a blind extrusion in the opposite direction. It may have deselected the region as well. So I'll see if I can fake it out here. So instead of blind, it's really disappointing that we can't do up to next. We can do it blind and then just set it to be here, somewhere that's inside the model, and we'll merge the results. So when all else fails, a blind extrusion does work. It's just not as clean. But you'll notice we have a little overhang there because we need to trim we need to move this slightly and make sure the difference between that edge is 0. So I'll make a quick edit here. Smart dimension. Distance between this edge and this one is 0. Okay. Now step out of the sketch, let it redo that. So now everything is all lined up the way it needs to be. All right. No unusual gaps, nothing weird to throw off our geometry. Now we can do our extrude cuts. So we're going to reference the same sketch. And we're going to do all of this region 5 millimeters. So all of that region 5 millimeters. That's step 1. So we're very, very close to our finished part. And then we need to do through all here. And I want to double check that those diameters are correct, because I think I didn't set those. So I'm going to go back and double check real quick. Radii for this, yeah, not quite. So 25 and 15. Like that. Now exit sketch. That's looking correct. All right, so 25, depth of 5 to a 15. One more extrude cut. This interior region through all. So now we have our 2 through alls. We have all of our detail for this part. And it can take a little bit of time, but you can be pretty efficient about your approach to how you go about it. And even a part like this that has some of these angles, hopefully this will help give you some kind of an idea. Go back and practice it a few different times, especially setting up angled reference planes. That's a little bit more advanced technique. Not hugely advanced, but enough to be worthy of note. So things to pay attention to. So make sure that in order to do this, you've got your ideas on how you're going to approach it before you just start drawing a rectangle for this part. and then a rectangle for this part. Because if you do this with 100 sketches and extrusions, it's going to take you 100 years, and you just don't have that kind of time on the exam. So 6061 alloy. So we're going to come in and set the material. Just make sure. So that'll be an aluminum. 6061 is pretty common. And now we look at evaluate. Let's look for center of mass. Because I think here, oh, they're just looking for the mass, the overall mass. So the overall mass is 2040.83 grams, which lines up very nicely with our 2040.57 there. So this is our answer for this one, and this is how we get there, to be exact, because you see how easy it would be if we had the wrong dimensions to be above that and come out with 2100, or to be well below that and be at 2000. Be very, very easy to do that. So we got to pay attention to all the little details there, especially what some of the stranger markings on some of these drawings mean, so that we know what we've got going on. All right. I think I've got time to try about one more part example. So I'll pull one more. I think we've done all the ones from this one in other videos. So I'm going to find one other one to pull from. So let's see. I think this one had one. So we've done this one in another video. I don't think we have done this one. So this one is all done in IPS. But it's fairly straightforward. So they do have a rib. There is a rib tool that can be used. In this case, it doesn't necessarily save a whole lot of time, but that might be a good additional one to take a look at. So what I want you guys to do is pause for a second, take a screenshot, give this part an attempt, and then come back and take a look at how the approach is done, see if it's the same, because this is a broken out section here, just trying to show you some relative thicknesses of things. So some of these details, 0.06 inches there, certainly important. So go ahead and take a crack at this one, see what you can get done. Note that the A and the B have specific dimensions here. So 2.125 and 1.25 for A and B respectively. And it's all done in IPS with alloy steel as a material. So there's this little cutout. So that's what you're seeing a part of here. So go ahead and create it and then come back. It's okay, I'll wait. No, really, I can sit here all day. If I get past the pain of your goldfish memory span, then you'll go start the part. All right, did you try it? Sure, I believe you. All right. So a part like this has a couple key features. This one is one of the instances where it's difficult to get all of the features on a single geometry. So instead of trying to do a profile from the side and extrude and then come back in and cut, it's probably best to do one from the base and then one from this side, one sketch from this side, and match them up. So we'll go ahead and create a new part. First things first, we'll switch over to IPS so that all of our dimensions will make sense. Then we'll go ahead and start a sketch. So this is one of the instances where it's okay to start from the base rectangle, because you can sketch a significant portion of this detail. The side profile, you can do it this way, kind of, and maybe for the sake of doing it differently than what your instinct is, we can give that a try, because you're still going to have to do a few sketches, but this way you could capture a good majority of the detail. So I guess we'll go ahead and give that a try, and then see what you guys think. You guys can try a couple different ways and see if one is faster and more intuitive for you or not. So we're going to have a rectangle and another rectangle and another rectangle, and we're going to have a line coming down from somewhere up here to somewhere down here, and then we're going to have something like that. So that's our approximate side profile. We're also going to need something like this, and we're going to need something like this. All right. So we're starting, that's, I guess, just a single feature, so I'll delete that second rectangle. We can get a pretty good idea what some of the heights are for recess holes and things. This one being off axis at 45s makes things a little bit fun, but still very doable. So we want to capture as much of this detail on the side as we can. So we have our thickness is going to be 0.75 inch. Our overall length is going to be half of 1.25 plus our A. So length is going to be half of 0.125 or 1.25 plus 2.125. So if you're struggling with math that day, I'm actually going to delete that whole thing. If you're struggling with math that day, the distance here is 1.25 over 2 plus 2.125 2.125, and then our height. So we'll come back to thickness. Our overall height here is going to be, we could start with the thickness of this one, so 0.75 for our effective diameter here. And the center line of this the distance between the center line and this base is what they're specifying here, which is a ½ inch above this base, which is itself a ½ inch thickness. So it's 1 inch above. So it should be 1.0 exactly. Okay. This whole height should be 0.5. This height should be, let's see, where do they specify this? So they specify an important thickness there. We'll come back to the radii. This, they give you the height here. They give you the radii for how things are rounded. That's very important. They give you the spacing and alignment for the holes. And I think the thickness of this region is one of the variables that they're leaving open-ended, so that you have to estimate based on what it looks like. And it appears to be approximately half, so 0.25. Given the fact that this is 0.9 or 0.2 almost, 0.25 and center line here is very reasonable, especially because they don't give you the height here either, but it's the same. So 0.25 inches is right probably where that plane exists. So this height needs to be 0.25 based on the sum total of that data. They give you a couple more pieces of information there. Like this has a radius of 0.1. And this has an overall diameter, or in this case, thickness, because we're going to do some cutting of this, has a thickness of 1.25. It's 1.25. This is going to be down below that surface, and this is going to be 30 degrees. So this is going to come up, yeah, that height is going to be 1 inch, so that will help. That height is going to be 1 inch, and it's going to be 30-degree angle. So let's set those two parameters. The height between here and here is going to be 0.75 because of dimensions and things. And then this angle is going to be 30 degrees. Now, 30 degrees or 20 degrees? Yeah, they say 20 degrees or 30 degrees. Okay, 30 degrees. So we need to shorten that length quite a bit. So sometimes you can get to a detail here. You can radius this with a sketch fillet at the end. I'm just trying to get fairly close to what we're looking for. So they want this to be in contact with the top. Okay. So this distance then needs to be 0. And then getting out of that tool, it's very interesting. So there we go. That will set a couple of our dimensions. We need to set the overall height. So this needs to be the 1 inch plus half of this outer radius, which is going to be the same as these, the 1.25 diameter, because it has to be. So the same 1.25, so 1.75 is our total height here. So 1.75 is our total height. I think this is still on the center line. It looks to be on the center line. So now I want to set the depth for that. So the depth for this is right here, 0.44 inches, and then this one is 0.375. So I can set these two, 0.375, 0.44 inches. Now we've got within reason, so some of this, like this height, you're not going to get a lot of detail about. So now we start fixing some of the geometric detail here and getting a pretty good idea what's going on with the overall geometry. So we've got enough detail there. I think that's about as much of the side detail as we're going to be able to make much use of. We'll have to do, I guess we can do the through holes. That'll be easy enough. So we do want to include those. So those are going to be probably about here. But I'm not going to associate them with a tie line to this because that'll create headache later. So this, I think, was 0.125 inch with a diameter of 0.136. There we go. So we can now do a through all cut of that hole. We're looking to see if there's any other part of the geometry. All of the rest of it requires things from other angles. So what we'll do is we'll do this. You're going to have a minor difference probably in the way that these get cut. We'll see. So there'll be some interesting things we'll get to learn. So we're going to do an extrusion the full width B, and then do some extrude cutting. So the full width of B is 1.25. All right. So even though this looks nothing like it, we're going to make a couple key pieces. In order to do the rib justice, the easiest thing to do is a reference point. So we're going to need to change that edge to a point, and then find a point up here. Because 3 points defines a plane, we're going to do one more extrude for that rib. So it has us in a sketch here on that plane. We want to get out of it. We want to do an extrude, reference that sketch. And we want to do from a surface or plane. From this plane, we want to do mid plane of this contour, and we want to do a thickness of what? They've been very, very clever with their dimensioning. This is 0.31. This rib thickness, because they don't specify it, this is where some of the geometry can get a little bit tricky. So we have to get just the aspect ratio about right. So what we need to do is we need to look critically about this and say this is for sure no more than 1/4 inch, which we know rationally. 1/4 inch for this rib, based on the other dimensions they're using, is about proportional to the amount that they're using there. It's going to be our best guess based on some of the features that they're using. So we're going to do a couple different extrude cuts. But in order to do that, we need a couple sketches here. So we're going to add a sketch to this face. We're going to change our orientation so that we can view what's going on. We're going to set the center line along this, but I'm not going to associate it with that point. I'm going to have it go through that point, but not be dependent on it, not be starting at that point. So this center line, we have a pretty good idea what's going on. So we don't want the center point of the center line. We actually want the center line here. So we know the height of these two because we've already been careful with our dimensions, so we're not guessing. So because of that, I don't have to do a whole lot of other extruding. The difference is I now need to do an extrude cut using, for instance, just this upper region. And this is going to go all the way back to this surface. So you're going to go from sketch point up to next. Actually, you're going to do up to surface. You're going to click here. So then we're going to use one of the older tricks. I can come back and edit this boss extrude because really I need this to also include this lower region here. So I'm going to clear these regions so that it becomes clear exactly what I'm cutting. So I'm going to do these regions only. So if I have to do a blind extrusion, I should be able to bring it up to a vertex. Should be able to do a lot of different things. Occasionally you'll get some weird errors, so I'm going to add a couple more regions here. So now it understands what we're doing, but it's still giving me issues. So I'm going to set it up to be a blind extrusion. And this depth is 0.44 inches. That's very interesting. This should be able to make that cut without any issues. So that's very interesting. I'm going to try this as a second extrude cut. Occasionally, you'll get some weird SolidWorks issues like this. So you just have to be ready for them. So I'm going to set this one up to be just a blind region. Cut these two at 0.44 inches. This is why I don't often recommend going this way. You can get to your ultimate goal this way, but sometimes you encounter some very weird behaviors if you're trying to just do let's see, let me edit this sketch so that I have a die section to cut with here. Sometimes you need a region like this, exterior. There we go. So even though I think this one got off of being vertical, I can still do an extrude cut. I can still reference that same sketch. And this time I'm going to extrude that through all. So now you're left with this geometry but we don't quite have a consistent arch here. Probably because our dimensions have a couple errors doing it this way. Because we've got a couple pieces of information, but they're really, really thin. I think this is why this particular part came off, as an example. So they don't do one like this anymore. They figured out that this one was confusing students unnecessarily, which does happen on occasion. So now we need one more thing on this sketch plane. We need this cutout. And so that appears to be 0.875 by 0.31. So down here, we're going to continue editing that sketch because we're going to need some of these key details here. 0.875 we can make a reference center line. And so long as it's horizontal, that's okay. We set the distance to be 0.25. We then set up our rectangle here. We set up our dimensions to be 0.875 by 0.31. I can reference that point. find the center line here, and that point, set that to a distance of 0, and then do my sketch fillet. Because it looks like, based on, I think what's wrong based on the geometry is this whole thing is narrower than it needs to be. That may be part of my issue here. So that's very interesting. Yeah. Because I think I didn't account for the thickness, so I'll have to go in and make some adjustments to the overall dimensions. So 0.875, and we have this centered on the model, even though it may not look like it from different angles. We're going to do our sketch fillet. These are going to be smaller, however. They need to be 0.03, I believe. .03. Yep, radius 0.03, and that's going to be recessed in to a depth of this thickness. So we're going to do quick math. 4 plus 0.375 minus 0.06. So our recessed depth is 0.755. So we do one more step out of this. Ignore the errors. Nobody cares about errors. We're going to have to redo them again anyway. Does not do a cut intersection with the model. That's interesting. So I'm going to cancel that operation. This is part of the reason why building some of these features with positive methods instead of subtractive methods can be very helpful. So let me go really mess things up and go back to the original boss extrude, because what this did, I went to the 1.25 inch, which should be okay. That's very interesting. So it should be 1.25 inch. That's correct. That is the width of this part. It's very interesting. So that actually is correct. I think my cut extrude geometries here may be incorrect. Very interesting. So this may be incorrect because I didn't set dimensions on this. Interesting. Very, very interesting. All right. So that's going to reset my heights All right. So now we're going to have to go make edits to the cut extrude. This is part of the fun of trying to take a different method. So instead of up to surface, I'm going to have to do blind. And what I'm going to have to do is instead, I'm going to have to make these cuts. I'm going to have to go through all as step 1. Okay. Step 2 is going to be, we're going to cut these regions. Oh, and this is going to make life fun. Good. I'm going to need to make another base rectangle down here. So let's do that. Ignore the warning errors and create the other base rectangle, because you need to be able to extrude cut as if you had a cutting die. So you guys have seen examples of this before. All right. Yes, yes. All right. The regions of interest now are these regions here. Okay. There we go. We got that corrected. So now, instead, we're going to set a depth from the surface, which is going to be this surface, using this region, and this region. And this is where we're going to use that bizarre 755 depth. Minus our 0.44, because we're taking away that. Minus our 0.44 is 0.315. So we're going to change this to 315. There we go. We have our recess cut there. So we're getting to the correct geometry, but I would posit the argument that this probably doesn't save you any time trying to do it with this particular method. So, we need a sketch on this surface. So that center line and even this edge need to be some lesser distance, 1.25 over 2. Get this centered. And then same deal. This needs to be separated from this edge by 1.25 over 2, so that gets centered. Then you've got another inner circle, this one set up at 0.75. Now we're sort of getting somewhere, but only sort of. and a rectangle to do our cutting with, to make our cutting die. This is why I'm a fan of primarily using additive techniques, because they reduce some of the confusion. This is going to be through all. Another extrude cut from that same sketch. This is going to be up to surface, this surface. And it's going to create errors. Of course it's going to create errors. Up to, because of the way that this geometry meets, trying to do this with a subtractive method is very hard. Possible, but very hard. Another easy way to approach this is actually to make this a rectangular extrusion, merge it with the surface, and then do a cut from the side. That's another method of doing it. There's also ways that you can do that using the rib tool. So in this case, I'm going to stick with blind and have it do a depth of 0.25, because I just have to try and brute force this method, which is tough. Oh, sketch 4, that's why. All right. So those two regions alone, without the rest of the sketch, should be resolvable. Maybe with those two. Now I'm going to cut into that. So I'll have to change the dimensions of that base sketch. So let me change the dimensions of that base sketch so that rectangle is so that's going to create a problem with this cut extrude because of the same resolving issues. You're basically going to have to create this tiny little region on that sketch. You're going to have to create this tiny little region from here to here, because don't ask questions you don't want the answer to. This zero conflict geometries game is rough. Nope, it didn't even use that line. All right. So now we're going to cut with that region. And now it's fine. Why? Because reasons. Long story. You could figure it out. It would make your brain hurt. You probably don't want to. So now we just need to punch the other two holes and set up the cuts. And that's relatively straightforward. You do another reference plane. You can even pick an edge like this one. And trying to get another surface so that I can do a 45-degree reference. Change that to be an edge. Get rid of these that are confusing. I actually want that to be 45 with respect to that edge. On that face, 45 degrees with respect to the face. And this edge. There we go. So 1. Now we do the same for 2. We can reference that plane and do perpendicular, which will give us what we want. So it's quick and dirty, but it works. Second reference is going to be this edge. So we hit OK. So now we have a center line on this. You can use the copy features and things as well. Okay. So we have our center line. We need to set the distance between this bottom edge and this center line to be, instead of 0.25 like it is right now, it actually needs to be 0.5 minus 0.19. Minus 0.19. And then because of where this is situated, we want to kind of line it up with that axis. So we can also, just so that you know, we can also set our view at exactly 45 degrees. And this way, when we set up our view, we can get our diameter, which is 0.136. So same as the other hole on this side. So we do an extrude cut. We can set it to be a mid-plane, half-inch mid-plane, half-inch mid-plane will do. And then you can copy feature. So we can do that as an option. But we don't actually want a linear pattern. We would actually want a circular pattern. And we would want this with regard to 90-degree separation about. So features, cut, extrude, direction of this axis. And now we have our second one. So there's a few ways to approach this, but this will give you a pretty good range or pretty good idea. And then as far as materials, they want this to be alloy steel. So we'll go ahead and get that set up. See how far off we are. So this may have about the same density as what they're considering. We look over to evaluate, and we find 0.47 pounds, which is exactly correct. So you can get there from here even without all the key dimensions, but it's hard to do. So some methods are going to take you way more time on a part. Sometimes you start wrong, make a mistake. If that's the case, try and think of how to make the best of it. Don't go restart completely from scratch, but practice, practice, practice. This is how you get better at stuff. So give these guys a try, and then hopefully have some good luck in some of the new parts, and I will see you guys next week.